welcome to the Spatial Structures Movers and Shakers interview series, as we look ahead to the IASS Annual Symposium and Spatial Structures Conference taking place at the University of Surrey in August 2021. My name is Mark Richardson, and today I'm joined by Terri Boake, who is a professor in the School of Architecture at the University of Waterloo. Terri's research interests include construction technology, low carbon design, and steel construction. Terri, thanks so much for taking the time to join us today.
You're very welcome.
It's a pleasure to have you on the Movers and Shakers interview series. We begin by asking our guests about lockdown. How has the lockdown period been for you in Canada?
Well, it's interesting you should ask, because I went on a teaching sabbatical beginning January last year, and that meant that I was sequestered in my house voluntarily writing a book.
Okay.
And so when the lockdown started, I'd already been sort of chained to my computer doing everything online for about 3 months. So mine's been a bit longer than most people.
Oh, okay.
But it does say that you can still be really productive. And I think we've all learned, particularly because I'm a professor of architecture as well, been involved in teaching this past fall a substantial number of online courses. It's, we're managing, and I think we're learning new things. But the numbers in Canada are finally like on the decline yet again, and so that's giving a little bit of hope. Plus, days are getting a bit longer, and summer soon.
Okay, great. Thank you for that, Terri. And we're also exploring our guests' career journeys and career paths. Perhaps you could give us an overview of your own career journey to date.
Certainly. I studied architecture at the University of Waterloo, started there in 1975, and I proceeded to do a Master of Architecture at the University of Toronto, following because I graduated into the big recession of 1982, where no one got work, and I ended up going back to Waterloo to teach building construction and structures, and in the end found myself with a career as a professor rather than in industry. And so I've been teaching for a very, very long time, and I truly enjoy the experience of the students and sort of exploring the change in architecture over the past 40 or so years with them. It's been phenomenal.
Amazing. Yeah, very impressive career there. And maybe you could tell us about a research paper or a project that you are currently working on.
Well, I just finished the last book which was on complex steel structures, that was published by Berkhauser in August of 2021. 2020, excuse me, I'm thinking ahead. So right now I'm in a sort of a regroup mode, because a lot of my my research and exploration of structural design is based on visiting building sites. And the problem with COVID, of course, is that there's not much happening here, not much that I can see. So at this point, I'm working through all the millions of photographs that I've taken over the years, of which you'll see some in the presentation, and trying to parse out how I can take information that I already have and breathe new life into it as a new set of publications, or as a new sort of specialty vein of exploration.
Excellent. That sounds great. And appreciate your answer there, Terri. We're now going to move on to the middle section of our interview, which is entitled Your Space, Your Structure. So I will hand over the presentation to Terri, who will be presenting on a spatial structures topic of interest to her. So over to you, Terri.
Thank you. Well, I wanted to start again a little bit with my journey. I was accepted simultaneously into architecture and engineering at Waterloo. As you can see from my credentials, I end up with a Bachelor of Environmental Studies, a Bachelor of Architecture, a Master of Architecture, and I'm a LEED accredited professional. But I have to say that the inner engineer was always there, and it was always lurking behind everything I did. And so I think my career trajectory as an architecture professor has always been influenced by my inner engineer. And in fact, I spend most of my time these days, when I do attend conferences, attending engineering conferences and talking to engineers, because I find the field incredibly interesting. And I think the merging of engineering and architecture, as you can see in these sort of high profile projects that really started to shape my interest in architecture at the Sainsbury Center, the Pompidou Center, and Frank Gehry's Pritzker Pavilion, were very sort of formative in my thinking about steel at a time in architectural design when nobody else seemed to be particularly interested in it. High tech, not much. Decon, yes. And anecdotally, I mean, Frank Gehry, when I was a student, would come to the University of Waterloo because he's Canadian from Toronto, and we used to have Thursday night hockey midnight, and Frank actually played with the students back in the day. And so as I sort of went through my teaching, I was somewhat distanced from real construction just by the nature of the beast. And then we ended up in Toronto with some really high profile projects. We had Calatravas, BCE Place, which you can see on the left, which I didn't have the chance of seeing under construction. It was one of those, it miraculously appeared because I don't live downtown. And then it Will Alsop's OCAD building in the center and Norman Foster's Leslie Dan School of Pharmacy on the right. And as you can see, when we look at the image on the right, I was on the construction site for that one. And being on the construction site and understanding the reality of putting things together gave me an entirely new perspective on architecture, construction, steel, and the way things work. And so I took great joy in hanging out on construction sites and actually just watching the ironworkers and understanding how they put things together and how they solve problems, because both the curved steel and the lifting of the pods, which we can see at the left on Leslie Dan, and the diagrid structure on the Royal Ontario Museum edition by Daniel Libeskind on the right, were really difficult and challenging projects. And I was so impressed by the quality of the ironworkers who, I mean, coming from an architecture background myself and understanding difficulties in construction, these gentlemen never lost their cool when they were putting things together, even if there were multiple tries at getting something to fit. And that really, really resonated with me. So the other aspect of the me part of things is me with my camera. And so what I began to bring to my research, this sort of new life of research, how do things get built, was the photography, the details, trying to get up close, trying to go in with my zoom lens if I wasn't actually allowed access to the site, and trying to see things, how things went together. Because that was something that I could bring both to my required research as a professor. It is true, you publish or perish, as well as trying to bring interest for my students with anecdotes and images and information that they were not going to find in their textbook. So I ended up working with the Canadian Institute of Steel Construction on their guide for specifying architecturally exposed structural steel. And that work started in around 2005, and I published the little guidebook on the upper left. And then I was discovered by an editor at Berghauser, Andreas Müller, who invited me to write my first book, Understanding Steel Design, whereby I just went through my entire slide library and pulled out everything I could find on steel and tried to put together a manual for architects and architecture students how to go about designing with steel. And when I'd finished that in 2011, I was depleted, I was exhausted. And I thought, well, that's it. I did the book. And he went, no. You're not finished yet. You have 3 more books that you need to do. And so I looked inside the first book and said, well, what could I expand on? And naturally, the subject of architecturally exposed structural steel it was easy for that one to become an entire volume. But the other aspect, and the one that links me into spatial structures, is the work on diagrid structures. Because what I noticed when I was in the design studio at school is that they were very fashionable in studio courses, but nobody really knew how to design them. They just were applying them visually onto their studio projects. And then I started to look at, on my own research, how could I help the students with this work that they were trying to do? What was out there? And so I discovered the work of Kyung-Sun Moon at Yale University, who was looking in detail from a mathematical and structural perspective on optimization. And so I read every paper that Kyung had put together. And that seemed to be it. There didn't seem to be anything larger. There was not a book on the topic. So I decided to make that the topic of my research. And so I went online, I investigated everything that the Council on Tall Buildings and Urban Habitat had to offer on structural systems. And I came up with this suite of projects and looked at them and said, well, like, this was quite attainable. I could look at every single one of these buildings because this was it in terms of constructed or visionary diagrid structures. The ones I couldn't visit were the Shukov Towers, and lucky for me, my colleague Elizabeth English had done her PhD thesis on that, so I had lots of information there. The Lotte Super Tower that was proposed by SOM wasn't built, but I had good contact with Bill Baker to find information on that. And I also had people at Farrell Partnership that could give me information on the first version of the Changzhou Tower. And then Tornado Tower and Doha Tower, I were not able to visit because I had no access to Qatar. So I started to just examine these buildings and take them apart and look at their details and tried to come up with a methodology. So from the Shukov Tower, which was a hollow support system for water towers that had no floors, to Swiss Re, which would be the first contemporary diagrid tower, where Foster actually did reference back to the Shukov towers as a precedent, which one can see pretty clearly in the example. And then when I was actually doing some work over in the UK, which was sadly my last visit over there was 2013, which makes me sad. I so enjoy visiting the UK. The cheese grater was under construction. And I also had a colleague that I'd met through conferences who was working at Arup. And the other thing that I noticed when I was looking at all of the buildings would be that 2/3 of them had Arup on the team. So I thought, if I'm trying to do, in-depth research, I need to contact Arup. And so they were nice enough to allow me to sit in their offices for 1 week in a February of my reading week, and then just go through all of their files, go through their papers, through their photographs to help me with my work. And so, adding to that, we've got the Capitol Gate Tower on the left, which was the furthest backward leaning one. There was one I ended up getting a site tour actually after the book was published, which was done, the polydiagrid, the Diamond Lantern, which is in Beijing, which I got a site tour. And then I happened to be in New York on another bit of business when the Hearst Tower was going up. And so the idea to me is that you really have to experience things in person. There's only so much that you can get from reading the information of others. There is just nothing that replaces a good old-fashioned site visit. And so when I went through all the information, I came up with a methodology so that we looked at modules and modularity, node and member design. The cores on every single one of these buildings were different. And what was revealed to me from the structural engineering perspective was that a true diagrid doesn't need a core, that all of the gravity and lateral loads should be able to be handled by that perimeter diagrid that has no vertical columns. So I started to look at the varying examples of cores: facade, glazing, expression, interior and exterior diagrids, and then technology, wind, and seismic issues. So that was the essence of the text. But a lot of it drilled down to this first push by Kyung-Sun Moon in terms of optimization. So when I was looking at the Lotte Super Tower that was proposed by SOM, they had gone through a huge amount of research in terms of actual optimization of super tall towers. So this was to be 555 meters tall, and they used parametric design to take it from very steep columns at the base, which were more useful in resisting moment and taking the gravity loads down, to quite sloped columns at the top with a round pattern. And so the faceting on the building was also used in the wind design to fool the wind, to trick the wind, and to deal with vortex shedding. And so this is a little bit of the charts that they gave to me on their optimization study in terms of the forces and to come up with the angles. But in the end, it looked to me that for the most part, it wasn't engineering at all that was pushing these projects. It was architectural design, and the slopes on very few of them had anything to do with optimization. They had to do with the shape of the building and the look of the building. And from that research, I started to focus more on the node itself, because to me, and then again with spatial structures, this is the big aha moment with diagrids. We do not see many diagrid buildings still being constructed, because in spite of the fact that they can theoretically save on the weight of the steel, which should save some cost, the engineering and the construction and the fabrication is more than an orthogonally framed building. But this idea of nodes as being a way to receive and transfer loads from various angles was a good takeaway for other more complex projects. And so if we look at the basic definition of a node, a point at which lines or pathways intersect or branch, a central or connecting point, this to me is the connection between sort of lightweight systems and diagrid systems and heavier construction that is now looking at nodes as being really efficient ways to transfer forces. And so if we look at node construction, we've got the Expo 67 in Montreal dome by Buckminster Fuller. We've got the Water Cube on the top right, and we have the Museum of the Future in Dubai. These nodal constructions are all designed to solve strange angular connections. And so we go then to more grid shell structures, which I think you've seen some of these in some of the previous presentations. We've got the British Museum, we've got Gehry structure in Berlin on the right, and we've got the Shanghai Expo in the center. All of these are heavily reliant on very specialized nodal constructions to transfer. And so I wanted to spend this little bit of talk just talking about node design criteria, because I think it's one of the newest areas in terms of structural design. And so with respect to diagrid structures, was it a concealed or an exposed project? What was the shape of the incoming members? Are we site bolting or welding? That turns out to be very geographical in terms of safety issues. Are the members independent or integrated with the node? Shop fabrication was important. How many incoming members and the weight of the node pertaining to lifting when it comes to the crane size. And so this is the node design for the Hearst Tower. And you can see from the central photograph how large the base connections were. But this is the point at which X steel transforms into Tekla structures and really begins to allow and facilitate more of this to go on in terms of design. But nonetheless, WSP shared with me some of these other diagrams of their nodal explorations, and you can see that simultaneously they were working through a lot of these connection details the old-fashioned way and also with hand drawing. Not to mention, I was so surprised to see them working through with balsa wood or basswood structures just to try to understand the three-dimensionality. Because I think with all kinds of spatial structures, it's the 3D geometries and the visualization that's really challenging. And so Hearst, the node at Hearst had quite a bit of influence on Alder headquarters in the UAE, on the Bow and Canna in Calgary in terms of the connection methods. If we look at the node design for Swiss Re, we can see something that is much more sleek, and even the way that the load paths are designed to go through, one might expect it. It looks so nice to be exposed, but in fact, it was designed to be sleek so that the enclosure system could be extremely tight. But you can see the clean lines and the geometry through the node itself. And so that also held on the node design for Capitol Gate in the UK, excuse me, in the UAE. These are images by Jeff Schofield, who was the design architect for the project. And these are some of the interior connections whereby the member shape was changed, but the idea of having the plates running through the center as a way to accommodate these varying geometries was the similarity between the exterior and the interior node design. And a bit of trickery in the finish detailing to cover up the bolted connections. These ended up being coated with an intumescent coating, which is quite thick because they were exposed and therefore they needed to have a certain fire resistance rating. The Leadenhall building, I was as I said, I was in London when this one was going together. And so it was also really interesting to see sort of fine variations in terms of plate thicknesses for all of these custom designed members. There's a huge preference in North America and Europe for site bolting for reasons of safety. The same would hold true for Australia. But these were shared with me by the design engineer for the project, showing how they were beginning to manipulate the interior of the connecting detail, doubling up the plates in some cases, and trying to accommodate varying geometries and varying numbers of members. And so we saw all sorts of variations of this sort of geometry of the node on different kinds of projects. This is the Al-Bahar Towers. They look like a pair of corn cobs, which are in Abu Dhabi. There you can see them there, and those are the nodes on the right. You can see the predominance of bolting that is used to do this connection detail. Steel is not a very common construction material. In the Middle East, you see a lot more concrete. And so the idea of using bolting makes it easier to use the workers that are available more easily. Welding requires a lot more site expertise. As I said, Australia also uses bolted connections, and Brookfield Multiplex Australasia actually sort of forbids welding at height. And so that's something that's really important to know when you're doing a project in different parts of the world. What kind of method of construction is deemed to be acceptable? In China, and this is the Guangzhou IFC designed by Wilkinson and Eyre, everything was welded. These are concrete filled tubes, and this kind of construction is absolutely normal in China. You would be hard pressed to construct something like this in North America or Europe because of the construction methodology. So this is again the poly diamond lantern in Beijing using concrete filled steel tubes and all welded construction. And here you can see the design of the node and some of the site connections that would have been done at height. The Canton Tower was interesting in terms of it also being a concrete filled steel tube structure, all welded, but here the node ends up being incorporated into the member itself as opposed to being a unique item on its own. Anyone who went to the London Olympics would be familiar with this lovely structure by Cecil Bellman done with Arup, whereby here again we've got the plate that's being used to create the juncture between the members, but in this case the node and the members are one, and there's just simply bolted plate connections between. This is the Museum of the Future in Dubai, and again we're looking at a tubular structure, but they wanted it to be very tightly clad. So this, although it looks like it could be exposed, in fact will be completely concealed, but they used all welded connections here in order to keep everything super tight for the cladding. So as I alluded to at the beginning when we looked at the Hearst Tower, the evolution of structural design and fabrication software has been critical to allowing so much to happen in terms of complex structures, as well as diagrid structures. So this is a Tekla image of the Rom crystal in Toronto by Daniel Libeskind. And these kinds of drawings allow the fabricators to go into each and every connection detail and design the bolts, design the welds, do the shop drawings. And so we end up with a digital model that precisely matches the constructed piece. And in something this complicated, that's so necessary because there's no room for slippage. There's no room for error. Otherwise, it just won't fit. And so this is a single sheet of drawings for one element on that project. So you imagine that the software has improved to the point where one element, one sheet of drawings, we could never have done this before. This is another element from that where they actually became quite affectionate and nicknamed it the owl in the fabrication shop because that's what it looked like. And again, looking at projects from the point of view of constructability and the iron workers and problem solving, I think it's paramount in anybody involved in architecture and engineering how to put things together. We have to understand that our designs are impacted by and impact the people who construct them. So the idea of the node spread to more complex buildings, sort of escaped sort of the diagrid, escaped the lattice grid. And this is a lift at 1 Manhattan West in New York City, whereby that piece that's being lifted, it was a tandem lift. They needed 2 cranes. It was over top of railway tracks, so there wasn't anywhere to put a tower crane. And just lifting that one piece, the column and that central piece, the node, all in one. The amount of skill and the amount of thinking and expertise that requires, to me, is quite phenomenal. And so, to me, it's all about the node that comes out of the whole study of diagrid towers, because in and of themselves, there's still not that many of them around. And so we have a new technology that has been translated to other kinds of building construction. So there's a node, a cast node that's in the center of the central diagram, which is a project in downtown Toronto. And then we have a fabricated node out of plate steel, all rolled, bent, welded on the right, which is at the shed in New York City. So you can see again this construction photographs of the shed, as well as the finished photos. So I think sort of one of the bigger takeaways is teamwork. And I wanted to share with you, as somebody who is an architect with an inner engineer who wrote a book on diagrid structures, who had to ask engineers for and fabricators for information and images to buoy up my understanding and my knowledge. This was such a treat to get this from Ahmad Raminian, who was the director of building structures at WSP, who worked on the Hearst Tower, and to have him, thank me for sending a copy of the book. It would have been so helpful when they were designing the Hearst Tower a decade and a half ago. I mean, that was, to me, made writing the book completely worthwhile. And so the diagrid structures I talked about today, the book that I just completed in my COVID lockdown, is Complex Steel Structures, Non-Orthogonal Geometries and Building with Steel. And there's a lot more information in that book on complexity and on node design in general. And with that, I will hand the interview back to Mark.
Terri, thank you very much for your presentation there. That was a wonderful insight into diagrid structures, very much enjoyed. And as you alluded to in the presentation, it is all about the node. So thank you very much for taking us through that. We now move to the final section of our interview, which looks at the future of spatial structures, and in particular the 2021 conference. Now, a key theme of the 2021 conference is inspiring the next generation. What advice would you offer to aspiring architects and engineers looking to enter the field of spatial structures?
Well, one of the things that I alluded to in the talk, and it's a little bit difficult during COVID, but we're going to get through this, we will, is to get out and look at things. I mean, I always say to my students when they come in first year directly from high school or secondary school, I said, like, shut your eyes and then open them and see things differently. Because for me, it was life-changing to start to go to building construction sites and to imagine that you're just doing drawings. You're not seeing the reality. We don't make lines. We are drawing elements. We are drawing materials. We are drawing someone's work. Someone has to put that together. And I think the more that you can understand that you're designing a real structure, the better off you'll be, and the more potential your work will have to achieve a degree of excellence. So even if you can't get on the building site, stand on the sidewalk, really have a good look at things.
I think that's great advice. Thank you for that, Terri. And our final question in the interview, what do you think are the most pressing challenges in the field of spatial structures with respect to some of the current global challenges?
I do think the access to materials and access to quality workmanship is quite critical, because diagrid structures, spatial structures, they need to fit precisely. And I think to look very closely at the available talent, the available workforce, fabrication facilities. And as I said, communication is really important. So if you're dealing with steel, talk to the fabricator, include that person or that part of the team in your overall conversation, because everything these days, I think, hinges on greater degrees of expertise. And the more people that you can get in before the problems start on the site, the better.
Terri, thank you very much for talking to us today on the Movers and Shakers interview series. It was a pleasure to have you on and to see your presentation. For those watching our series, please be advised that registration for the 2021 conference is now open. Do visit the conference website for more information. And if you're enjoying the Movers and Shakers interview series, do remember to like, share and comment on our videos. All of your thoughts and views are very much appreciated. But for now, Terri, thank you again for taking us through your presentation today, and hopefully we will get the opportunity to catch up with you again on the Movers and Shakers interview series as we move closer to the 2021 conference. But for now, thank you and see you soon.
Great, thank you very much.
Bye, Terri.
Bye-bye.